So the practice example. Now remember for the centroid, it does bisect the median. Well, not bisect. It intersects the median at about 2/3 from the vertex. So um, that's the only thing we know about that. Hmm. So let's say we have a triangle given like this, and given that P is the centroid of the triangle JKL, meaning it is everything that bisect, everything that contains this point P from the vertex is going to be the median of the shape of the triangle. Meaning AE is a median, CD is a median. Sorry, wrong thing. Um, JN is a median, KO is a median, LM is a median, and so here we're also given some length. JK, the whole JK is going to be 22. So let's go ahead and label that in. Uh, KN, this little part right here, is going to be, let's see, 13. And OL, OL, OLO is 18. Well, that's nice. So that's the given. Now, because it is a centroid, the median does do does did bisect the segment. So meaning JO, let's call it one markers, is going to be congruent to OL, right? So we can find JO because of that fact. And once we know what JO is, we can find JL by adding the two together. We also know that since JK, the midpoint of JK would be M, as it is that it is the intersection from the median. JM and JK is going to be the same. So if we know that JK is 22 and JM and JK MK being the same, we can find out what each of them will be. So what two of the same number when added together give you 22. What number multiplied by 2 give you 22. And for Kn, this segment would be congruent to NL, as N is the intersection through the collinear with the centroid from the vertex J. So if we know Jn, so Kn, we can find NL. So Km can be found. NL, because these are congruent, can be found. KL, once we know what Kn and NL is, we can use the additive property to combine them. And JL, once we find JO, we can add it with OL to make it into JL. So those can be found. I hope you understand what you want to do here. Okay. So I applied it. Now remember with diagram, if you don't have one, draw one up. If you do have one, go ahead and fill it in. Label as much as you can. Make a diagram big enough that it is usable. In this case, it's big enough, it's usable. Number 2, Z is the centroid. So again, any line from the vertex through the centroid will intersect the opposite side at the midpoint. So X is going to be the midpoint. So this segment, TX and XU will be congruent. Y is going to be a midpoint. So YU and YV is going to be congruent. Let's go ahead and do a double mark. We already have a single mark. And W going through the vertex from the, going through the centroid from the vertex. We mean that TW and WV are going to be congruent. So without doing anything else, just the fact that it is the centroid, we can go ahead and claim these facts on our diagram. And you do want to do this. So TZ in this case is defined to be 60. Okay. So now remember, it is the centroid, so that means the segment from the vertex to the centroid is twice of the centroid to the midpoint. So if this is 60, if this is x, then this is 2x. Mm-hmm. So with that, we should be able to find zy. Okay, xz, xz is 28. So if this is x, if this is y, then zv is going to be 2y. So if we know xz, then we can find zv. And once we have zv, we can add those two together to find xv as it should be. Okay. Finally, wz is 25. Wz is 25, and again, this is the centroid to the midpoint, so it is only one value, so let's call that value z, and so zu is going to be twice of that, so twice of 2 times wz is going to be the same as zu. So we can find that once we have so that will give us zu. Actually, since this is a first example, let's go through all this together. All right. So since these are midpoint and segment by sector, km is going to be half of 22. So this will be 11 on both cases. And L is going to be congruent to Kn. So NL is going to be 13 just by looking at it. Can't do much. KL is NL and Kn together. So 2 times 13 because they're congruent, or 26. JO is congruent to OL, so JO will be 18. And JL, 18 and 18 together, give us a sum of 36. So we want to be able to do this part. Okay. Similarly, on this side, this is addition essentially, and over here, because we're looking at the the segment from the vertex through the centroid, we can divide it up into either 2 times or 1 time. Okay. So we already talked about how TZ is given as 60. So if TZ is 60 and that's twice of ZY, then ZY is going to be just half of 60. 60 divided by 2, or that is 30. ZV is 2 times of XZ, and XZ was defined as 28. So we're going to double that, 28 times 2. So we have the length of the midpoint to the centroid. We can multiply it by 2 to find the remaining length, or multiplying by 3 to find the whole thing. So that's good too. That gives us 56 units. TY, sorry, ZV. Oh, did I do ZU? Yeah, I did that. Yeah, that should be 50. 25. Okay. ZV. ZV is 2 times 28. So 2 times 28, and that gives us 56. ZU is twice of WZ, so that's why we're going to do 2 times 25. And that'll give us a total of 50, a product of 50. TY, sorry. TY is the whole segment, so there's 2 ways you can do this. TY is, sorry, 2 over 3 TY, right? This is 2/3 of the whole thing. It's the same as TZ, right? And so since TZ is 60, we can say that 2 over 3 TY is 60, or TY by itself would be 3 over 2, the reciprocal of your multiplier, times 60. Now you don't have to do this, but it is the short way to do this, algebraic way to do it. But this will give us about 90 as the length of TY. Of course, you can divide 60 by 2 to find ZY, that is 30, and add the 2 to get your 60. sorry, to get you 90. But algebraically, that's what we can do. XV, we have ZV that was 56. We have XZ that is 28. So XV is gonna be a total of, I want to say, 784. Okay, so this is what we're gonna have for our assignment. Okay, let's set this up. I'm gonna let you guys find the actual distance ourselves, and we can check it at the end. Yeah, at the end. Okay, so G again is a centroid, so AG is going to be 2/3, well, twice of GD. AG in this case is 8, so GD can be found by taking 8 divided by 2. GF is going to be half of CG, because G again is centroid, CF is the median. GF being 7 mean that CG is going to be a decimal when you divide. Sorry, no, you can find GC by multiplying by 2, since GF is the segment from the centroid to the midpoint. BG is 5. So BG is 5, meaning we can, that would be interesting, wouldn't it? No, BG is 5, so that means GE is going to be twice, 2 times 5. Right? So that allows us to find GE, and once you have GE, you can add the 2 to get BE. AG can help you find GD, because remember AG is twice of GD, so you just find half of it to find GD. Once you have GD, you can find AD. GF is about half of CG, so to find CG, we'll just double the segment from the centroid to the midpoint, and that will give us CG. And once we have that, we can find CF. Right, so we don't have to do the multiplication if we need to. Well, technically you're multiplying and dividing, but you don't have to use the fraction multiplication if you don't want to. But that's just the way it is. Okay, that's number 3. You can, well, let's see, GD, did we talk about that? Yeah, we talk about GD, we talk about AD, because once you have GD, AG and GD together, we use AD. CG, we talk about that, because that is twice of FG. GE, we talk about that, again, that's twice of BE, because E is vertex, so if you have a vertex, you better double it up, or multiply it by 2, or divide by 2. Yeah. So the vertex portion is always 2 times as much. Just as nope, I can't think of anybody in class that's gonna be 2 times as much. That's fine though. Where are we? GE, yeah, we did that. BE, then once you have GE, we can end up with BG, BG, GE, to get a total of BG. So use the additive property. Okay, hopefully that helps. Let's look at number 4. So for this one, X again is the centroid, and because it is a centroid, this median line will bisect the. No, I guess we're not doing the side. Okay, but they do bisect, so just keep that in mind. So the side has been bisected. All of them will have evenly, but we don't have to know all of it. What we do know is the segment from the centroid to the midpoint, or the centroid to the vertex, is always 1 to 2 ratio. We have 1 here. This is twice of that. So TU, we know TU. Oh well, the whole thing is 27. So if TU is 27, this is 1/3 of TU, and this is 2/3 of TU. And when I say of TU, I expect you guys to know that we are multiplying this ratio to the whole length to find the partial length. So that's what we multiply by, right? The short side multiplied by 1/3 of the whole thing, and long side multiplied by, well, to find long side we multiply 2/3 by the whole thing. Okay, so we know TU, we can find that by multiplying the appropriate ratio of the segment. And for SW is 18, so this whole thing is 18. So we can multiply again 2/3 to find SW, and multiply it by 1/3 to find XW. So xs, sx will be multiplied 18 by 2/3, xw multiplied 18 by 1/3. Okay, and RV is the segment. The whole thing is 21 units. So the same idea. Rx to the from the vertex to the centroid is about 2/3 of the whole length, and xv will be 1/3 of the whole length. All right, so use your note. I believe we did discuss that. Um, if you have a centroid, then it is the whole length can be multiplied by 1/3 or 2/3 to find the long and short, to find this segment from the vertex to the median midpoint. Otherwise, it's the other one. Okay, so use that fact to help you find these things. I will help you. If you have any questions, just let me know. Okay, all right, number 5, 6, 7, 8, and 9. So same idea to do these. Remember, since we do have a diagram, we don't have to draw it out, but we do want to label it as much as possible. J is the centroid, so this is 1 to 2. DH is 51, so multiply from D to J will be 51 times 2/3, and J to H is 51 times 1/3. Right, so this is always by third. Sorry, that should be a 3. And so these are our facts. Now, how do we prove it? I have no proof of this, not yet. Alright, but for now we need to make use of the facts, and a lot of time we have things we don't understand, but we know how it is used, and we know what we can expect as a result when we do it certainly in a certain way. You expect the computer to turn on and get into a window when it's finished running. So it's the same thing. You don't have to know completely how the computer works, but we know there are properties that we can make use of, and that's what we're going to do. Alright, so the edge is going to be 51. GF is going to be 60, so multiply that by 1/3 and 2/3 to find the appropriate segment. And EI will be 57, so again multiply this by 1/3 and 2/3 for the appropriate segment. So from the vertex to centroid, we are multiplied, we have, it is 2/3 of the whole thing. Okay. From the centroid to the midpoint, it is 1/3 of the whole thing. So together, it'll be the whole thing. That's just not. Yep, that's the idea. So see if we can apply this. I will check it on you as you work on this. Number 6, V is the centroid of PQR. We have SR as 21. So again, 21 times 1/3 for the short piece, and 21 times 2/3 for the long piece. VU is just a third of the thing. So VU will be an 8. This is one part. And so QU, called QV, will be twice of that. And we need to know what that is to find the whole thing. Well, we could do that. We can also divide it by, because VU being the short part, we can divide it by 1/3 to find the whole thing. If we need to find the whole thing instead of the other piece, the other segment, or the half, well, or the third, or the 2/3 of the segment. PT is 15. So PT is 15. Since this is the whole length of the median, we can go ahead and do 15 times 1/3 to find VT, and 15 times, I hope you guessed it, so 2/3 to find PV. Right, so finding these allow us to, with the whole segment, we can multiply with the corresponding ratio to find the vertex to centroid segment, or the centroid to midpoint segment. That's our multiplier. Okay, so applied and practice. Okay. Okay, so G is the centroid. So great, we have centroid. Whenever we have centroid, it's 2/3 and 1/3 for vertex or to midpoint. BF is the whole length of these vertex. So 1 1/3 BF will give you the midpoint to the midpoint from the centroid, and 2/3 times the length of BF will give you the length from the vertex to the centroid. So match it up, apply it in. AC, AC is 20. AC is 64, and F then is the midpoint, meaning AF and FC will be congruent. We just need to find the length. What number added to itself will give you 64. What number multiplied by 2 will give you 64, and that will give us AC. Half of AC will give you AF or FC. Okay. And GE. GE is this little segment. So this is 27. And so if GE is 27, then we can find GE. We can use GE to find AG. As you know, GE is, if G is 1, AG will be twice of that, doubling it up. So if G is 27, AG will be 27 times 2. Okay. So that will give you a chance to find AG. Okay. So we can apply that, and yeah. Once we have AG, we can multiply. We can also multiply because GE being the segment from the centroid to the midpoint, we can multiply it by 3 since it is 1/3 of the whole segment AE. So multiply that by multiplying the GE by 3 will give us AG. Okay, so these are things you can use. You don't have to write this part the way you need to. That'll give us the corresponding values. All right, number 8. Let's see if we can set this up. The centroid is T, so we do have a centroid inside, and T is 16. So we have the vertex to the centroid as 16. So this is 2/3 of the whole length, and so QT will be 1/3 of the whole length, or that is half of TN. You can find out what that is by doing the operation suggested. If you're not listening to this, good luck. Well, no, I know you can. I know you can actually figure it out from the note we had up to this point. So, but I haven't write any answer just yet. I want you to try this, and we'll go on from there. All right, MQ. MQ is 23. So this is the whole. Well, no, MQ is 23, right? Not just MP. So that means PQ is 23. And so if PQ and MQ are 23, then MP is 2 times 23. Yeah, I mean, that's the idea, right? RP is 18. RP is 18, so the whole segment is 18 units. And again, RT is only 1/3 of that, and TP is about 2/3 of that. Now, for fraction, when you multiply them, remember you are dividing the denominator, dividing the bottom number, dividing it by 3, and then multiply the result by 2. Right? Multiply the product by 2. So that will give us the ratio. That is the fraction. It just means you divide it. You have a multiplication, even though we just do a multiplication. The fraction is a division, and we are doing both. Okay, so it's just a way to maintain what is it, integer, rather than having decimal approximation. All right, RP, we did that. So we deal with NT because that's just the length from the centroid to the vertex. We can find another one by dividing half, and find the whole by adding the 2 together. MQ give us half of the side, so that means the other half would have to be the same, and the whole thing would be twice that. RP is the whole median, and so centroid to the vertex will be 2/3 of it, and centroid to the median side midpoint will be 1/3 of that. So nothing weird, just applied and make use. Number 9. H is the centroid of the triangle. So luckily we have a centroid as opposed to incenter and circumcenter. So we have definition, and we need to be able to differentiate them. Before we differentiate 2, now we can differentiate 4. Is there a way we can get all of these to be the same? probably with a regular polygon. That tend to happen more often than not. Uh, so H is the centroid of the triangle BDF, DDF, and DF is 50. I'm doing DF, not E. Um, so that means DE being congruent to EF will be half of that 50. So you got two guys in the gang. They'll take with 50. Each of them get half of it, obviously. If not, somebody's not gonna be happy, right? CF is 42, and so the whole thing is 42. The midpoint to the centroid is going to be 1/3. The vertex to the centroid will be 2/3. And these, when I say 1/3 and 2/3, I'm talking about 1/3 and 2/3 of the whole length, 42 units. So we do need to multiply and place it appropriately. BH, this from vertex to the centroid is 22. And again, this is 2 times the centroid to the segment. So to find the short segment HE, you have to, divide it by 2. That's the idea. All right, so see if you can apply this. I will check it on you. If you have any question, let me know. Moving on to the back. So for this next portion, we want to use our note to answer these. If you don't have your notes, I suggest you take it. It's super short. You can copy. You don't have to listen. Some of you don't want to, and I know I don't want to either. So here we are. All right, so the 3 perpendicular. So when we're looking at circumcenter, right, if you go back to your circumcenter note, you need to be able to do this. If you go back to your circumcenter, the circumcenter have 3. Because it is a circumcenter, it is perpendicular bisector. You're bisecting it, so that way the the circumcenter to the vertex are always going to be congruent. Right? So even though your perpendicular bisector to the circumcenter are not congruent, that circumcenter, the opposite will always be congruent. For the incenter, it is the opposite of perpendicular bisector. It is going to be the angle bisector. That is, that's what we bisecting here. All right, so in this lesson, for this week and last week, we have been looking at 3 bisector and 1 perpendicular. That is the altitude. Okay. Number 3, the 3 median of triangle. Sorry, the centroid. We've been talking about that on the previous page. Right, centroid is where we have the midpoint and vertex, opposite vertex. So the 3 medians, the length from the vertex to the centroid will be congruent. You can do this. You don't have to. You can actually stop early. Consider this yourself. Orthocenter is from altitude. You can kind of, it's up here. The notes right there. So altitude of the triangle will intersect at the orthocenter. Now here's the question for you: can the orthocenter be outside? Outside of the triangle? If you say yes, then why? And if you say no, then why? Right? When will the altitude be outside of the? When will the orthocenter be outside of the triangle? Think about that. Okay. A blank is equal distance from the vertices of a triangle. Right. So this is a circumcenter. We talk about that with the perpendicular bisector. Since it came from the side, the length to the vertex will be the same. So circumcenter happen this way. And similarly, the angle bisector will not always have the same length from all three vertex, but it is going to be the same distance from the side. So the incenter will be equal distance from the side of a triangle. Okay, so that would be the practice. Well, this portion is just a center review. I will give you a review assignment so you guys can fill this out. I think I gave it to you already, but if I have not, that's fine. We'll fix that. Okay. Otherwise, good luck.